Welcome, everyone, to the future of web development with ASP.NET Core and Blazor. Thank you for being here. It's great to be back at Visual Studio Live. I'm Daniel Roth. I'm Principal Product Manager on the .NET team for ASP.NET Core and Blazor.
And I'm Mike Kistler. I'm also a Product Manager on the ASP.NET Core team.
So in this session, we're going to look at all of the new features and improvements coming to ASP.NET Core in .NET 10. That's the plan. ASP.NET Core is our complete modern web framework for .NET. It's included with the .NET platform. It has everything you need to build high-performance, secure, scalable web apps, APIs, and other back-end services. It comes with an entire array of web technologies. It includes Blazor for building rich interactive web UI using C#, minimal APIs, so you can build fast HTTP API endpoints with minimal code, SignalR, so you can handle real-time web communication, gRPC for ultra-fast back-end remote procedural calls, lots of built-in middleware, so you can customize your request handling pipeline with authentication, routing, caching, and so on, and then Kestrel, our industry-leading high-performance web server. ASP.NET Core is today used by over 2 million developers every month, and that number just continues to grow. It powers some of the largest services in the world. It's used by Microsoft 365, by Bing, Teams, Copilot, Xbox, and most of our Azure services. One of the many reasons why Microsoft uses ASP.NET Core is because of its industry-leading performance. In the recent Tech Empower Fortunes benchmark, ASP.NET Core was 3 times faster than Express.js, and I think it was 5 times faster than Gin, which is a really popular Go-based framework. And with each .NET release, we keep making it faster. So ASP.NET Core is a mature and robust web framework that provides a solid foundation for all of your cloud-native and AI application needs. ASP.NET Core integrates seamlessly with the new .NET platform capabilities for using AI in your applications. Microsoft Extensions AI is a library that provides AI primitives and abstractions and building blocks for working with generative AI in your apps. The Evaluations library helps you evaluate the quality and safety of your AI applications. The Vector Data library helps you integrate with vector databases so you can add semantic search and embeddings to your apps. We provide AI-powered templates so you can quickly get started building rich chat interfaces with .NET and Blazor. We have the new C# Model Context Protocol SDK or MCP SDK so that you can extend AI apps with new tools and data. And then Semantic Kernel provides orchestration for multi-agent workflows to handle complex processes. To learn more about using .NET with AI, you can go to .NET/AI. ASP.NET Core is also ASP.NET Core loves .NET Aspire, which provides a great way to build, test, and then deploy apps seamlessly to the cloud. It's really easy actually to add .NET Aspire to your existing ASP.NET Core apps. It's not like a different app model or a different world. It's built for ASP.NET Core. When you add it to your apps, it lights up all sorts of functionality like open telemetry, resiliency, health checks, HTTPS, and so on. So your app is ready for the cloud. You can then streamline your developer experience using design time orchestration and service discovery. Just get your entire app running all at once on your dev box. You can use the .NET Aspire integration packages to quickly connect to services like Redis or PostgreSQL or AI services. You can easily see your metrics, your logs, your traces using the built-in .NET Aspire dashboard. And then when you're ready to deploy your app, you can publish it to any cloud or hosting environment you want using Aspire's flexible deployment model. It's really a great solution. If you haven't tried out .NET Aspire yet, I encourage you to do so. We think you will love it. You can learn about .NET Aspire at .NET/Aspire. Or for a more practical introduction, I encourage you to watch one of the Aspire Fridays live streams that the Aspire team has been hosting. They've been taking real customers with real ASP.NET Core apps and then Aspire enabling them live on the internet. So you can check those out. They're a lot of fun to watch. Okay, so what's then next for ASP.NET Core? Well, we're already hard at work on .NET 10, the next major release of the .NET platform. In ASP.NET Core, we're focused on these 4 key areas. The first is security, making it easier to create secure apps. Security is obviously more important than ever before. At Microsoft, we're invested in our own security with the Secure Future initiative, and we want to make it easier for you to build secure apps too. App observability and diagnostics. We want to make it easy for you to monitor and diagnose your applications with more metrics, logs, and traces. Targeted performance improvements. We want to make sure this is the fastest release of ASP.NET Core yet, so you get more throughput, faster load time, and while using less memory. And then finally, we want to address top pain points and feature gaps. We really want to take the time this release to address some of those long-standing issues, fill in those feature gaps so that developing with ASP.NET Core is a delightful experience. Now, today we're going to go through each of these 4 areas in detail. And the first one we're going to talk about is security. Mike, tell us about security.
Thanks, Dan. Yep, secure apps. We're all about, in .NET 10, trying to help you to build the most secure apps that you can. One aspect of this is making sure that we are providing the latest security standards, support for the latest security standards in the .NET framework. And one of these is support for WebAuthn and passkeys. And I'll talk about that more in another slide. The next thing is to make sure that authentication is easy for you to adopt and use. All the security features in the world are no good if you can't figure out how to use them. So we're working hard to make sure that our security features are very accessible. One thing that we're doing there is we're adding support for new scaffolding that will let you scaffold in authentication into an existing app. I'll talk more about that later. But then another thing is just a major reorganization of our identity and authentication documentation. We've gotten a lot of feedback through social media and through GitHub issues that people have a hard time finding information in our documentation. Sometimes they find it in multiple places, and sometimes it doesn't even agree. So we're making a major effort to fix that in .NET 10, and you'll see more of that as .NET 10 comes. So WebAuthn and passkey support. Just quickly, for those who might not be really familiar with passkeys, what are passkeys? These are a new type of cryptographic credential that replace traditional passwords, or at least can supplement additional passwords. They're phishing resistant, they're easy to use, and they're secure by design, and I'll show you more about that in a minute. The way passkeys work is that when you create a passkey, it's basically a public and private key pair, and the private key is stored in an authenticator. Now, an authenticator is kind of a conceptual thing. Physically, it might be a security key like a YubiKey. It might be an application on your device like Microsoft Authenticator. It might be a cloud service like iCloud Keychain. But basically, the important thing about the authenticator is it holds that private key, and it will never let that private key out. It may sign things with that private key as a way of attesting that you are who you say you are, but it never lets that private key out, and that authenticator manages that. The other thing that's important about those private keys is that they're tied to a particular application, what we call relying party in WebAuthn terminology, and to a particular user account. And that means you can't actually share passkeys across accounts or across websites, which is one of the big reasons why passwords are so unsafe. All right, so is the next thing, I have one more slide talking specifically about what we've done in ASP.NET Core. We've added passkey support into ASP.NET Identity Framework. Okay, Identity Framework is the built-in identity system that's available in ASP.NET Core, and we've added support for passkeys there. This is based off of some support that was built into a popular open source library called FIDO2NetLib. We worked with the maintainer of that library. We figured out what were the important pieces that we really needed to provide to ASP.NET Core users, and we've now incorporated those into our framework. We haven't taken everything because there are certain pieces of the protocol that are still evolving, and we didn't want to put something into the framework and then have to change it later and cause breaking changes. So one of the examples of this is something called attestation, which is a way for a relying party to only accept certain authenticators when it's accepting a passkey. So we didn't take that because that's still evolving. We've added support to passkeys to our project templates. So I'll show you in a minute when you do Blazor, .NET Blazor new, .NET new Blazor. Yep. You actually get passkey support right away when you use ASP.NET Core identity. We are also adding support to our scaffolders so that if you have an application that doesn't have authentication yet and you add authentication to it with ASP.NET Core identity, you'll get passkey support built in. And then we're also adding support where you can, or at least going to describe how you can take an application that already has ASP.NET Core identity and add passkey support to that. So all those things are coming. Now I'm going to show you a little demo of the passkey support. So right now I'm just in an empty project. Okay, all I have is my dev container here that's set up to run. Come back. Okay. Not sure what happened there. Little glitch. Okay, we're back. .NET list SDKs. So I have my 8 and 9, but I also have the preview 6 of .NET 10 here. Okay, and what I'm going to do is .NET new Blazor. And I'm going to say auth is individual. That's what gets you the ASP.NET Core identity added into the application. So just like that, we've got our new app. I didn't say I wanted passkeys. Like I said, they're built in, they're already there. Now, because ASP.NET Core identity has a database underneath it, I have to actually run that database. So I think I have that saved here. Just do that EF database update. That will get the database started. All right, and now I can just say .NET run. And this will be the familiar Blazor template that you see before. Get that loaded. Okay, so here's the Blazor template. Now there's an auth required page, and I haven't logged in yet. So when you go to that auth required page, it shoots you over to the login page. I haven't even registered a user yet, so I'll register as a new user. You can see that I've done this a few times. Down here and fine. Yeah, well, let me do that. So we'll pick my super secret passwords and put that in there.
Password, so old school.
So old school. Oh, yeah, because I actually pasted it into that.
Not a good idea to put your password in your username. I'm just saying.
All right, let's try this again. All right, so I'm registered. And now I click to confirm my account because I don't actually have the email stuff set up. And so now you can see that I'm able to log in with my password. Get this going one more time. Maybe it's still in my paste buffer. Yep, there we go. So I'm authenticated. It says, yes, we know who you are. Now I can come down here and in my account settings, and again, this is just the template that comes right out of the framework. We've got a new passkeys page. So now I can say, I want to add a new passkey. And now because I have Microsoft installed on here, I have to cancel out of this. But then I say, I want to use my Edge profile and I want to store this in my Edge profile. I have to touch the fingerprint sensor and I say,
so Edge profile is acting as your like authenticator app.
Edge profile is acting. Oops, I should have typed that all the way.
And then when you had to like put your fingerprint on, that was like the machine validating that you're really who you say you are. It's the user verification.
That's correct. That's correct. Okay, so now I've got my passkey installed into my app. So now let's log out. And now I can come back here and I want to say I want to log back in. and it says, oh, you have a saved passkey for this account. What do you know? Yes, I want to use that. I have to touch the fingerprint sensor again so that it knows that it's me. And there we go. I'm logged in, Mike Kistler.
Very nice.
That's it. So passkey support is now all built in.
That's great. Now, like Mike was saying, we want to make it easy for you to add authentication to your existing applications. So we're doing that in .NET 10 by adding some additional authentication scaffolders. Mike already mentioned that we have an ASP.NET Core identity scaffolder that we're updating with the passkey support. We're also adding some new scaffolders. We're planning to add one for Entra ID-based authentication so that you can set up your ASP.NET Core apps with Entra-based auth, including your Blazor web apps, which is a known gap in like the Blazor web app template. It doesn't currently have that option. With this scaffolder, we expect to fill that gap. These new scaffolders will be based off of the .NET Scaffold tool, which is a really great command line interactive tool for running scaffolders instead of having to pass like a whole bunch of command line arguments. We're also looking at adding a scaffolder for adding the ASP.NET Core identity endpoints, which are a way to programmatically interact with ASP.NET Core identity, like if you're building like a native mobile application. We also hope to have scaffolders for adding authentication to Blazor hybrid apps. These scaffolders are still a work in progress, so nothing to show yet, but we hope to have them available for you to try out later this year. All right, so that's security. Next up, let's talk about app observability and diagnostics. So in .NET 10, we want to make it easy for you to monitor and to diagnose issues with your ASP.NET Core apps. To do that, we're adding a ton more metrics. We're adding metrics for Kestrel's memory pool, for authentication and authorization, and also various Blazor-specific metrics. We're also adding new activities for Blazor Server to use with distributed tracing so that you can identify Blazor-specific actions like page navigations and UI events firing within your broader like Blazor Server style application. We're also adding diagnostic tools for Blazor WebAssembly apps so you can do things like take performance profiles and memory dumps. Let me show you a couple of these new features. I'm going to hop out of PowerPoint here. And I have this one. Let's go over here to my version of the Blazor app with identity already set up. And what I want to do is I want to show you some of the new metrics. And the easiest way to actually do that is using .NET Aspire. Because Aspire has this really awesome dashboard. So to add Aspire to my Blazor app, super easy. I just do add. And then I'm going to go here to .NET. Where did my screen go? I'm plugged in. Thank you. Duplicate.
There you go.
We good? All right. Sorry about that. Okay, we're back. So right-click, add .NET Aspire Orchestrator support. You guys see that? I know it's kind of small right there. Okay, so I'm going to click that, and that will bring up this dialog so that this is telling us that it's going to add a couple of projects to our solution. The two projects it will add are, first is an app host project. That's this guy right here. That basically like models your entire app, like all the different services that make up your application and knows about all their dependencies. And then we also have this service defaults project right here, which adds a bunch of helper code to set up all those features in ASP.NET Core that make it more cloud ready, like open telemetry, resiliency, health checks, and so forth. Now down here, it's where it wires up open telemetry, and currently it doesn't, the Aspire hasn't been updated with all the new .NET 10 metrics and traces yet, so I'm just gonna do a little code modification right here. Let me grab this snippet, and I'll add all the new ones so that we can see all those. So I'm just gonna replace this code right here, and you can see them already, right? Like there's the, all the new metrics that we're adding and all the new trace sources that are new in .NET 10. Otherwise, that code is exactly the same. So let's go ahead and run this. And when you run a .NET Aspire app, that app host project takes care of starting all the different processes that make up your app. So you can get the whole app running on your dev box really, really easily. And when it launches, it'll launch this really great .NET Aspire dashboard, which gives you fingertip access to all these this telemetry and diagnostic information. Okay, so if I click here, we can see the set of resources that make up my app. I just have one, which is my Blazor app. If I click on the URL for the Blazor app, we can launch it. There it is. Looks like the one Mike just showed us. I can go in and log in and say I want to log in with my passkey. Yep, let's use that one. I'm going to use my Windows Hello thing. Yes, it's me. All right, great. And I should be logged in. Yep, good. Okay, so I'm able to log in and I can click around. Let's also go to the counter to cause some Blazor server related events to happen. Okay, so I did a bunch of stuff. Now, back in the dashboard, we can click on the metrics tab and see all the metrics that are available from the runtime in our application. And here you can see all the new ones, like we've got all these new authentication and authorization metrics. We've got low-level component metrics and higher-level ones like, what event handlers have been fired and have you done any page navigations? So if we look at a couple of these, like let's look at the number of sign-ins. And the first time I looked at this, I was like, it's a little weird. I only logged in once. Why does it say 3? That's because it's counting for every different auth scheme that you have in your app. But you can filter these. Like if you go below, you see all these filters. You can say, I just want to see the application level logins. And there, lo and behold, yes, there was just one of those. The other ones were like it dealing with passkeys and those types of things. Similarly for Blazor, like if we look at like the page navigations for Blazor, you can see that I've obviously browsed around to several different pages in the app. And again, you can go down into the filters and see just the counts for specific pages. Like if I want to see just how many times did I go to the counter page? Well, I only went one time. So you can get some like basic telemetry for how your app is being used. You could also do that by the component type instead of by the route for the component. Okay, and then last thing I want to show is you can also, for people that build Blazor server apps, you can also see the number of active circuits that you have in your app. You get a circuit for each connected user to your Blazor server style application. Currently, I only have one because I just have one tab open on the counter page. But if I duplicate this tab so that we have, 2 users using my app, so one on the counter, the other one's on the counter. If we go back, you can see, yeah, now we have 2 circuits in our application. So you can monitor, how your app is being used, how much load is on your Blazor server application. So that's pretty nice. Those are the new metrics. For traces, if we go to the traces tab, again, for Blazor server style apps where you have that long running WebSocket connection, that was never very helpful to see in your distributed trace logs because it was just like one big long request. In .NET 10, we've cleaned that up so you can now see much more detail. Like up here, you can see right here is where we're starting the circuit, and you can see there's a trace activity that's identifying that specific circuit. And then below, if we scroll down a little bit, yeah, right here, you can see things like, oh, someone just triggered an on-click event handler, and that called the increment count method. So you can see individual UI events happening in the distributed trace. And if you click on one of these and expand it see its properties, you'll see below in this links section, it's all linked up to the back to its parent circuit and all the related UI events that have happened for that circuit. So you can track down for that particular user what's happening during their session. So that's the new Blazor server tracing functionality. What about for Blazor WebAssembly? We have new stuff for that too. We've got some cool new diagnostic tools. Let me switch out of this app. This was a Blazor server-based app. Let's get a Blazor WebAssembly app up here. One of the things you might want to do with your Blazor WebAssembly app is take some performance profiling data to find out, like maybe it's going a little slow. Why is it going slow? You can now do that using the browser dev tools in .NET 10. To set it up, you have to you need to install the WASM tools workload, which is a separate SDK workload. And then you also need to do a little bit of configuration on your Blazor WebAssembly project. You have to add a few MS Build properties. But after you've done that, you should be able to run your app. And then if we go to some WebAssembly stuff, let's go to the counter page. This is running on WebAssembly. And I'll bring up the browser dev tools here. Function lock. Okay, so is it running? Yes, okay. So we've got our browser dev tools up. And if I go to the performance tab and start a performance trace, let's record, and I'll click on the button a few times to cause some data to be generated. In the performance trace output, you can see we've got this new timings tab that will show up that we add. And if you expand that, back to the performance tab, expand that, you'll get this like flame chart style view of various timings of the .NET code that's executing within your application. Like basically I have one of these sort of flame spikes for every time that I clicked on the counter button. So you can get some basic performance analysis data within the browser. You can also export diagnostic information from your Blazor WebAssembly app so you can analyze it in your tool of choice. Like if you'd rather do this analysis in Visual Studio or using PerfView, you can do that too. Let me show you that. So I'm going to close this app. It takes a slightly different runtime configuration, but not too much different. Let me switch over to this Blazor Diagnostics project. So here again, you need the WASM tools workload installed, and you need to set a bunch of MS Build properties to tell the runtime, hey, make this data available. And then once you've done that, when you start your app and you go to the part that's using WebAssembly, you can now extract some diagnostic information from the application for external analysis. So let's go again to the counter page, and then running. Okay, and we do F12 again to bring up the browser dev tools. But this time, instead of going to the that's not what I wanted, the console. Instead of going to the browser performance profiler, we'll go to the dev console, and I'm just going to call some JavaScript APIs that we've added. So here you can get the .NET runtime and say, please collect some CPU samples. And I'd like to do that for 5 seconds. All right. So if I run that and then click to generate some .NET code running to analyze, then it downloads for me a net trace file. Okay. And then I should be able to, which one was it?
862.
Thank you. Mike was watching. He's done this before. All right. So somewhere in my downloads folder, I think it's just one anyway. Yeah, 862. Thank you, Mike. We can just open that up in Visual Studio, and this will look at all the data from our Blazor WebAssembly app, and we can do some performance analysis on the perf data that we just extracted. So that's getting like CPU samples. We can do other things too, like if we want to collect some metrics, some runtime metrics, you just call collect metrics. Again, I'll do it for 5 seconds. If we run that, click to generate some data. That'll generate the same sort of metrics that we were looking at in .NET Aspire, except now from a Blazor WebAssembly app. And again, you can open that up in Visual Studio. I think I'll skip that just in the interest of time. But the last bit that's kind of neat is you can also get memory dumps, like GC dumps. So if I just run collect GC dump, which is this call, it'll actually capture all the state of the memory and generate, it'll actually generate again a .NET trace file for that one too. I think it was 4765, which actually isn't it's not super convenient to open up in Visual Studio. Visual Studio really wants a GC dump file that's actually easy to generate from the net trace file. There's this tool called GC dump that you can run and just convert the trace file. And which one was it? That one, 4765, right? That's the right one? 4765. Yes. Okay, that's the one for the dump. Okay, now I've got a GC dump file, and that I should be able to open up in Visual Studio and be able to analyze my memory usage. Let's see if that works. And voila. Okay, so we can filter to our, what just happened? I must have hit the Windows button by accident. Filter for our counter component, and we can see our counter component and all the other related objects. Got it? Okay, so there you got diagnostic tools for Blazor WebAssembly, new metrics and new traces for the runtime and for Blazor applications. Okay, so that is observability and diagnostics. Next, let's talk about performance. How are we going to make ASP.NET Core the fastest release yet? So we're doing a number of optimizations in .NET 10. First of all, we're doing work on Kestrel's memory pool so that it can now release memory. And I'll talk more about that in detail in just a second. We're also doing work on JSON deserialization performance for APIs so that it uses the new pipe reader support, so it's much, much faster. You may remember we did similar work for the serialization side in .NET 9. So this is kind of like the other half of that effort. We've done a bunch of optimizations on anti-forgery in .NET 10, and we're also making some improvements to Blazor WebAssembly startup performance. All right, let me talk a little bit about the Kestrel memory pool. So Kestrel will pool memory as it uses it to be more efficient. And as the load on the server increases, it will actually increase the size of that memory pool because it needs more memory. But it never, at least currently, it doesn't ever release that memory. It just holds onto it so it can reuse it later. For most apps, it's perfectly fine. Doesn't matter. But if you're operating at hyperscale, this can be potentially an issue. Our friends in the Azure App Service team, they handle on the order of billions of requests per day. And they hit this as a problem. They noticed that if they had a large spike in traffic, Kestrel's memory pool would grow to handle that, but then it would stay at that high watermark and would never get released. And then they were using, they didn't have that server memory available to use. And they're asking, hey, can you make this a little bit more efficient? And we said, yeah, we can work with you on that. And so we experimented with them on different approaches, and we actually deployed some of these approaches into their production environment to see how they behaved. That's what those charts are on the left. You can see on the top chart, the amount of evicted memory from the memory pool is going up, which is what you want. We're freeing up memory. And then the total memory being used by the servers is going down. So obviously this is great for Azure App Service. They're making more efficient use of the memory on their servers. But it's also great for all of us. We all get lower idle costs, better scaling, smarter resource use because of Microsoft's experience using ASP.NET Core at scale. So pretty cool. So more efficient memory use in the Kestrel memory pool. For Blazor WebAssembly apps, we've done some optimizations to make those load faster. First thing we did is the Blazor framework scripts like blazor.web.js and dotnet.js, the actual .NET runtime script. Those are now just normal static web assets in your ASP.NET Core apps, which means that they get all the optimizations that we did for static web assets in .NET 9. Static web assets are like, your JavaScript files, your CSS files, those sorts of things. So they can now be fingerprinted, they can be pre-compressed, and they can be aggressively cached using normal browser infrastructure. We also did some work to now preload some of those assets, so you don't have to wait for like this waterfall of requests where you first load blazor-web.js, and then you load .NET.js, and then you load this. We can just like preload those files up front so your app loads more quickly. Let me show you what that looks like really fast. We still good? Yes. Okay. Let's switch to a different app here. Let's go to Blazor WASM Startup. So this is a Blazor WebAssembly app. Let's go ahead and run it to see what it looks like. And let's see if we can see some of these new optimizations. So I'm going to F12 to bring up the browser DevTools again and bring up the network tab. And let's just empty the cache and refresh to see everything that's being, I don't think that I think gotta clear out the local storage too. Let's make sure we are clean, so we can see all this stuff. Oh, well, it would help if I'm actually on the counter page that uses WebAssembly. There we go. I was like, where's all the files? Now, don't freak out when you see this long list of files. I know some people see this and they're like, oh my goodness, that's huge. During development, we don't do any like trimming on the application. We don't do a lot of the optimizations that we do once you publish the app. So if you publish this app, it will shrink way down and get much smaller. During development, we don't bother with those particular optimizations. But some of the new optimizations in .NET 10, you can absolutely see. So for example, here, you see .NET.js, it now has a fingerprint in its file name. It's a hash of its content. So if this file ever changes, and the name of the file will change, which means that for any given file, you can basically treat it as immutable. You can tell the browser, cache this forever. If it ever changes, I'll change the file name. So that's really nice. Similar for like Blazor Web.js. You can see down here, it's also getting fingerprinted and getting those nice optimizations. If we look in the HTML that got downloaded for this app, we can see there is a link tag, that's being generated right here. That's actually preloading .NET.js. You see that? It's got relationship rel preload set. So this is basically telling the browser, I'm going to need this file eventually. You might as well load it now. Don't bother to wait for Blazor Web.js to load it. Go ahead and get it. So you save on requests. And if we look inside of .NET.js, you can see it's also got this payload of data that it's now carrying. This is the data that used to live in blazor.boot.json, which was like a JSON manifest that was part of your application deployment. Basically, it told Blazor all the different parts of the app, all the different assets that it needed to download. Now all that data is just included with .NET.js as a build step, which means, again, that's one less request for your app to have to make in order to load. So that all loads faster. How is that all being set up? Well, if we look in the app, that link tag is actually being generated by a new custom component that we've added to the framework. Here it's called link preload. I think in preview 7, which is coming out shortly, it's now called resource preloader, I think. I think that's what it's called. Resource preload. That has a different name in preview 7, but same concept. It's what's generating that link tag. And then down below, we have this assets API on the server that lets us map the sort of the normal path to the file to their fingerprinted version of the path. And that's how we get the fingerprinted version of the Blazor Web.js to show up in the HTML. Now you may wonder, like, okay, that's great, but that all requires server code execution to set all that up. What about my standalone Blazor WebAssembly apps? Well, we have done these optimizations for those too. So if you just have a Blazor WebAssembly app that's a static site, you also get these improvements. And the way they're done is through some build time modifications of your index.html file. So here in index.html, this is a standalone Blazor WebAssembly app. So no app.razor. We just have a plain old static index.html file. You can see that there is a placeholder right here for the preload link tag. And at build time, this will get updated with the right file name and with the right fingerprint. And then down below, we also have a placeholder for Blazor WebAssembly.js, which has a placeholder for its fingerprinted name. And then the modifications are turned on using this MS build property that's included now in the project file. Okay, so you get exactly the same optimizations, even if you're deploying your app as a static web app. So those are your Blazor WebAssembly startup performance improvements. All right. What about on the back end?
All right.
Let's talk about top pain points and feature gaps that we're fixing.
Right. So as Dan said at the top, there were 4 major areas, and this is the 4th area, the area about pain points, right? And what we did was we looked at GitHub issues, and we looked at social media, and we looked at just sort of direct feedback from customers to try to figure out what were the things that really were causing developers pain. We wanted to try to fix those, make working with ASP.NET Core a delightful experience. Now, when we did that, we also were looking towards the future. We were looking towards what are the things that are going to really improve the experience for what we consider to be our modern web stack, right? And for APIs, that's minimal APIs with system text JSON. And that doesn't mean that we didn't do anything with controllers. We did some improvements for controllers as well, but we're really trying to look towards the future. That's our recommended web API framework going forward. So that's where we wanted to put our focus. So what did we look at? First of all, we looked at adding support for validation in minimal APIs. And I have a demo of that later. I'll show you what that looks like. But this was a big feature gap between controllers and minimal API. And it also ties into our other theme of security, because it's really important for API apps to validate all of the input that it gets coming in to make sure that it's not getting invalid input that can make it misbehave, right? So this is a key feature for minimal APIs. Another thing that we added was support for server-sent events. AI is a big thing, and a lot of the AI applications will stream results back from an LLM through these server-sent events. So we've added support for that in minimal APIs. We're continuing our support for OpenAPI. We're generating OpenAPI, and now in .NET 10, we are generating the latest version of the spec OpenAPI 3.1. That's on by default. You can obviously choose to have it generate earlier versions, but we're trying to keep up with the latest standards. We are also using the information in XML doc comments that we find in your code as another way of enriching that OpenAPI document that we're generating. I'll show you that in a minute. And we can generate that OpenAPI file in either JSON or YAML. Some people like YAML, so now you can get your OpenAPI document in YAML. Yes. Controversy. Yeah. All right. Finally, there's some other common backend pain points. One of them was in .NET 9 and earlier, we had support for JSON patch. You could implement a patch endpoint that accepted JSON patch, but that actually required you to bring in Newtonsoft.json, the old JSON framework. We hadn't updated that to use the new system text JSON, which is now the modern JSON framework that we're using. We've added support now for JSON patch with system text JSON in .NET 10. And there was one other pain point that came up pretty frequently, where if you had an application that had both a web app and web APIs in the same application, and there was an unauthorized request that came in, there was some confusion about how to handle that, because in a web app, you would want to redirect to the login page. Whereas for an API app, you would want to return a 401 or a 403, right? We've got that all sorted out, we think, in .NET 10. So now the APIs will do the right thing and send the return code, send the status code, whereas the web app will redirect to the login page. So
I'll show us some things.
I'll show you some things.
Swap again.
Okay. So I've got a little demo app here. This demo app is based off of the demo app that we've been now running for a while now called eShop. But what I did was I just extracted the catalog API service out of that so that we could just focus on that piece of it. You can see that here. And one of the things that I want to say is this is a minimal API app. Okay, it's using minimal APIs, but you can see that it has a structure, right? It has an API directory where all the endpoints are declared. It's got a data directory where you have all of your database things declared. It's got models and things like that. I want to point this out because we hear occasionally that people say, oh, we really like controllers because they give us that structure. Minimal APIs can have that same structure. You can use that same structure or whatever structure that you want, that whatever suits you in your minimal APIs. And this is a great example of how that can be done. Now, I said we added support for validation. The way that looks is much like it does in a controller-based app. You go to one of your models, and you can see that we have these attributes in here, right? Required or max length, min length. You can even have things like regular expressions where you say, what is what should this piece of data look like? You can have custom error messages. And there's some other nice features here. Actually, I guess I can just show you that right now. You can build your own items. Where is my... well, I lost that. So, oh, here it is, multiple of 10. So in the restock amount, this is going to be validated so that when it comes in, it's going to have to be a multiple of 10. And you can also validate the entire object, right? And what's nice about this is you can look at relationships between two pieces of the payload and make sure that they're in sync. So here I just have an example where if you're sending in a catalog item and it's a Gucci, but its price is less than $1,000, like, well, that can't be
That doesn't.
So let's see what this looks like. Fire this up. So we'll get this started. Now, I don't actually have to open the web app here. I'm just going to fire some commands at it from an HTTP file. So because this is an Aspire app, right? It's got a health endpoint, so you can see that health endpoint is active. We have our OpenAPI, and you can see now we're generating OpenAPI 3.1 by default. Okay. For the validation, I'll come down here to this item where this would do a creation of a new catalog item, and everything in here is correct, okay? But one of the things was the description had to be at least 10 characters. So I'm just going to cut a bunch of that out, right? And then we'll send that. We'll see what happens. Yep, it says this validation error occurred. The description field has to be at least 10 characters, right? Another item is that the SKU had to be a particular format. So we can change that and make that not match the format. And sure enough, it will catch that format error as well, that regex. Just to show you the fun part, reset that. So here I have my my special order running shoes. They were $149. I said they were brand of Zephyr. Let's just make this Gucci. Oops, but I have to.
Better Zephyr Gucci.
GCCI. I can type. Okay, there we go. All right. And there you can see that we actually hit that special validation check that I made.
Let's try trying to get those Gucci running shoes for only $150.
There you go.
What are you thinking?
There you go. There you go. So that's the validation support that we have now available. It's actually in the previews now. This is running preview 6. It's all there and working in preview 6. So give it a try. The next thing that I want to show you is some of the XML comments. Now, I showed you before that you can get the OpenAPI, and here's the OpenAPI coming back from the endpoint. And in components, we have our catalog items. Now you see here that we have, I should have, looks like I am on the validation endpoint. Well, so the description and the example that you see here that are coming out, these are actually coming from the catalog items. I thought I was going to have to update my project to do that, but I guess I had already integrated that. So where does that come from? That comes from, let me just clear that. get back to catalog items. So in catalog items, we have these XML comments on here. And prior to .NET 9 or prior to .NET 10, we wouldn't have actually incorporated these, but now the framework will actually find these and incorporate these. This summary becomes the description in the OpenAPI. This example gets shown as an example in the OpenAPI. Okay. And the important thing about this is that when your OpenAPI document is really high quality and has all of this good information in it, then all of your downstream tools work better. And one of the downstream tools that will work better is actually GitHub Copilot. And so let me just try this out here. We're gonna see how this works, Dan. So let me get the OpenAPI file up here. Not that one, this one. So here's my OpenAPI file. And I'm going to open my Copilot. And I'm going to, it's in Sonnet and it's agent mode. Okay, that's important. So we're going to say, generate an HTTP file to test endpoints in this open API.
You can see it has like the OpenAPI doc in its context, so it knows about the file.
Yep. Because I had it open, it said, okay, I'm going to load that into the context, and now it's just going to go and read this. It can also go and find other things in the project, and I think at one point it will go and it will look at the actual implementation, and it will look at that as well as this OpenAPI. It goes and finds the existing HTTP file, actually, which is important because it knows what the port is that it's going to use. Sometimes when I've run this, it will add it to the existing HTTP file, and sometimes when I run it, it decides to create a brand new HTTP file. So you kind of have to roll with it, or maybe give it very explicit instructions if you want one or the other. But so there we go. And this time, what did it do? It actually created a new HTTP file. Okay. It's using localhost 7516. Let's just say keep that. And when we look back at this, sure enough, it went and got that same endpoint. And here we have some catalog test endpoints. Get all the items. So we'll just try running that. And sure enough, that worked. You can see it's got a whole bunch of tests here. Let's just try one more thing here. This should return a 400.
It does like positive cases. I can see like it's got a negative case. For like,
that's right.
Too short.
That's right. That's right. So this is what you get. This is one of the benefits that you get from having a very highly accurate OpenAPI file generated out of your application. And we think that we've given you a lot of new tools to be able to do that. That's it.
Cool. That's awesome. Love GitHub Copilot. It's so much fun to watch what it does. You know, when you should be doing other work, right? And you just like, I just want to sit there and see what it's doing. Look, it's amazing. Look what it's doing. It's pretty cool. Okay, so that's addressing top pain points and feature gaps on the back end. What about for the front end? Well, we're doing the same thing there too. And for front end development, our main investment is in Blazor, which is our most comprehensive and flexible .NET Web UI offering. We, of course, still support our older frameworks like MVC and Razor Pages, and also building your front end with popular front end JavaScript frameworks, Angular, React, Vue, and so on. But Blazor is really where we're spending our time and energy. It's our recommended way to build a web UI with .NET. So we want to make it really great in .NET 10. What are we doing? Well, in .NET 10, first of all, we're adding first-class support for component state persistence. And I'll talk a little bit more about what that means in just a bit. We're doing some work to make the behavior of Blazor more consistent across its various render modes, like when you're doing page navigations or handling not found requests. We're fixing some issues with how the scroll position behaves when you're using Blazor's enhanced navigation feature. We're adding some commonly requested features to our built-in data grid component, the quick grid. We're smoothing out and improving our JavaScript interop story. And we're also adding a first-class support for doing automated browser testing for like Blazor apps using Web Application Factory and Kestrel. Now, a little word about Blazor state persistence. So remember before we were looking at a Blazor server app, and Blazor server apps are inherently stateful, right? Like they have some server state for each connected user to the application. We call that state a circuit. And what state persistence is the ability to persist the component state so that it can be reused later. Now, we already have some support for this in Blazor, specifically for pre-rendering. Pre-rendering is when you take your components and you render them first from the server, so you can get HTML down to the browser as fast as possible, while the components then render again interactively, so you can set up all the interactive features. So that's pre-rendering. And you want to avoid, when the components render twice, you'd like to reuse the state, so you don't have to go fetch it twice. Like you don't want to hit the database twice to request exactly the same data. And it also helps smooth out the user experience. So we have support where you can persist the state that was used during pre-rendering and then reuse it when the components render interactively. And we do that using a service called persistent component state. And it's been there pre.NET 10, been there for a while. It's okay. Like it's not the cleanest coding pattern to use, but it's there. In .NET 10, we want to make it really simple. So we're adding a declarative model where you just add an attribute to like a component property to say, this is state of this component that needs to be persisted, and you're done. So that's how you can handle your pre-rendering persisted state going forward. We also want to make your Blazor server apps more resilient. When a circuit gets disconnected from the user, like let's say the user's network connection has a blip in it, or maybe they're on their phone, right? And they're looking at the browser and then they swipe away from the browser to go to a different app, like to check their email. When you do that, the browser goes into the background and usually the phone will like put it to sleep and then it kills all its network connections. On the server side, Blazor will see that the user's disconnected and it will hold on to the circuit state for a little while. I think the default is like 3 minutes. But after that, it'll be like, I guess that user's not coming back. And then it evicts the circuit. If the user then does come back, there's no circuit to reconnect to. Blazor will create a new circuit for them, but their old state is now lost, and that's not a great experience. So what we want to do in .NET 10 is we're adding a way so that we can persist the state of the circuits before they get evicted, so that when the user reconnects again, they can have their state and it's still there, and they can keep going at what they were doing. Lastly, we think we can also improve the scalability of Blazor server apps with state persistence. For every user that you have connected to your app, you have this circuit state, and that's server resources that you're spending on that user. And sometimes they might not be doing much with that state. Like maybe they opened the app in the browser, they were starting to use your Blazor server app, and then they went to lunch for an hour. And now that circuit is just sitting there idle, not doing anything. In .NET 10, we're giving you APIs so that you can define a policy for when would you like to proactively pause your circuits. Pausing basically means persist it and then evict it. And then later resume it when you know the user is back and wants to use that circuit again. So, example policy might be if the browser's not visible, then the user's not using the app probably. So you could pause the circuit and free up those server resources. And when the browser becomes visible again, you could resume that circuit and bring those resources back. So that can make your app more scalable. This won't be something that we do automatically, but it's something we'll provide you the APIs so that you can do yourself. Okay? So that's a lot of stuff. I'm gonna, in the remaining time, let's see how many demos we can get through. We'll look at all the new front-end features that we've got coming to you. Oop, go back. There we go. So let's go see here. So let's start out with some basic new Blazor goodies. Let's open this one. Okay, so here I have an app. It's just a basic app that has a quick grid component. Let me go ahead and run it. It's got a quick grid component that's displaying you can see it's displaying a filtered list of movies. Okay, so we'll get this running. There we go. I think we can close this other one. Let's snap that side by side with Visual Studio so we can play with some new features. Okay, now first thing, so we got our list of movies. First thing I want to do is I'd like to be able to style rows in my quick grid based on the data that's in that row. Like maybe I want to pop the the newer movies and, kind of mute a bit the older movies. We now have a way to do that in .NET 10. I'll just switch branches to show the code. We have the only thing that changed is we added this row class parameter right here. So this row class parameter basically says, and it's a little cut off, but here's the data for the row, and then you return a CSS class that you want to apply to that row if you'd like. So here we're saying if the release year is greater than 1999, then that's a new movie. Otherwise, I think it's old, right? Yeah, then it says it's old. Okay, so CSS class of new or old. And if I hot reload that into the application, I've already got some CSS set up for that. And you can see the new movies are now showing up as blue and the old movies are showing up as gray. So that's how you can style rows based off of their data. Another thing you might want to do is this app has this little column options widget. So you can do filtering. Like if I want to filter to just movies with rings in them, I can do that. When I hit enter, it applies the filter, but the column options UI, that little widget, still sticks around until I click off of it. That's kind of annoying. Can I fix that? Well, the code for that column options UI is right over here. You can see this column options tag, and you can see all it's doing currently is binding to the title filter to figure out what do you want to filter on. But if we update that, let me switch to column option, closing the column options. So all we added in this change is this guy right here. So now we're saying after the data binding is done, let's grab a reference to the movie QuickGrid, the QuickGrid component, and we'll call this new method hide column options async, which allows you to make the column options disappear. All right, so now if I hot reload that into the application, and let's clear that. If I hit enter, like immediately the filter is applying. Let's try like looking for movies with matrix in the name, enter, and I see the filter applied and the column options goes away. So that's kind of nice. A third thing is handling of not found responses. So new in .NET 10, in the template, in the Blazor web app template, we now set you up with a not found.razor page. See that? And if we click on that, we can see it's just got some basic markup. But we've configured this page in two places. We've configured it on the router. So here in the router, you can see that it's now got this new not found page parameter that we're pointing to that not found page. So if the router tries to route to something that doesn't exist, it'll basically render that page. Similarly, on the server, in Program CS, we have set up the use status code pages middleware to basically say if a 404 happens, then also render the not found page. So that should now work. So if I go to like slash, I don't know, foo, which is not a page in my app, then I get my not found page to render. You can also manually trigger this to happen by calling navigation manager dot not found. Last thing that we added to the template, which is kind of neat, is when in a Blazor server app, when the user gets disconnected, let me go back to the homepage. When the user gets disconnected, there's usually like a UI that shows up in a Blazor app to say, hey, I can't connect to the server. Hold on, I'm trying. And it tries to reconnect, and you can provide an experience around that. There was a way to customize that UI previously, but it was a little bit cumbersome. So we decided to just include that UI directly in the template so you can then customize it however you want. So this is the default reconnection UI code. Let's give it a little bit more color by adding some emojis, like, a phone if you're trying to rejoin the server, and a sad frowny face if for some reason we're not able to reconnect. So we'll go ahead and hot reload that in. And so now if I shut down the server so that the connection gets lost, hopefully should see, hopefully there's no server. Why are you not detecting that it's not there? I don't know. Let me try that. Let's refresh. I think my hot reload didn't quite go through because I switched branches. All right, so now if I shut this down, there we go. So now we're getting our reconnection UI with our customization, so you can customize it however you'd like. So that's kind of nice. How much time do I got? Okay, a little more time. So one more I want to show is Mike showed validation with minimal APIs. That validation logic is actually built on some common infrastructure that we are also using now in Blazor. Now, Blazor's always had validation support, but we only would ever validate like the top level properties of your model type. We didn't have support for really validating the whole object graph. I think we had like an old preview package that you could use for this, but we never actually shipped a stable version of it, and people were really annoyed by that. They're like, will you please ship this library? We're like, yeah, we know, we'll get to it eventually. But now with the new validation support that was added for minimal APIs, we have that functionality, so we're just using it in Blazor. So in this app, we've got an edit form right here. So a basic form, which is using an order model. And if we look at that model type, we can see that it's a deeply nested model. Like here's our orders model. It's got customer details. It's got order items, which is like a collection. If we look at the customer model for the customer details, it's got an address. And the address has a bunch of properties. And all these things have data annotations on them to say, this needs to be validated. This needs to be validated. Previously, Blazor would only do like the order model, top level properties. It wouldn't dig down into the instance. If you now turn on the new validation features in .NET 10 by calling add validation in your project, you can now get full complex object validation. So let's try this out. So if we bring up that form, there's a form for some sort of order. I don't know, let's order some pizzas. Actually, let's go ahead and just submit the form without putting anything. You can see that I'm getting validation errors throughout the entire object graph, or the whole form that's binding to different parts of that object graph. And as we fill in things start to work fine. So if I like mistype my email address, it's like, no, that's not an email address. So that's working. If we like send this to Microsoft, and zip code, and what should we order? How about what kind of pizzas? Hawaiian, of course, right? But of course, I know the pineapple stuff is controversial, so no pineapple on the Hawaiian pizza. And let's order 200 of them. That's too many. So let's do 12, and well, it's okay. So there's full object graph validation as well. What if you want to like do end-to-end testing on your Blazor applications? Well, we have new support for integration testing using the built-in web application factory infrastructure. So in this app, what we've got is we have a Blazor application. Bring over the Solution Explorer. We have a Blazor application that we want to test. And so we're going to use this web application factory type. This is a really cool type that can actually set up a complete in-memory pipeline for your whole ASP.NET Core app. And then it can give you like an HTTP client that you can then use to send requests to it. And using the web application factory, you can then customize the app. Like you can, say, I'd like to swap out some services for testing purposes for the testing environment. So that's all well and good. That works really well actually for like backend APIs where you really do want to just take an HTTP client and send requests. If it's a Blazor app or MVC or Razor Pages app, it might not be enough. I mean, you could send an HTTP client request and get some HTML back and then try to parse the HTML. But honestly, if you're doing like any JavaScript interop or any of those types of things, you might really need the whole browser web platform there to really test it. But you couldn't do that before with Web Application Factory because you couldn't actually it didn't actually stand up a real endpoint for the browser to point to. It was doing everything in memory. Well, in .NET 10, we've now fixed that. So if we go to the weather page test, which is testing a Blazor page, you can see this was the old pattern, right? Where you would, create your web application factory and you could create an HTTP client and start sending requests. But now we can actually say, please use Kestrel and please start the server. So I now have an actual endpoint, an actual port that I'm listening on. And then we can do things like here, you can see we're using Playwright in this integration test to do full integration testing of our Blazor app using the web application factory infrastructure. There were a lot of people that had like kind of hacked their way to get to this point with all sorts of nasty reflection and things, but now it's built into the framework so you can just use it. Okay, the last demo I want to show is the state persistence work. So remember we talked about state persistence for pre-rendering. So let's look at what that used to look like. So I've got this Blazor pre-rendering app. Okay, so here's an app similar to the app we saw before that's displaying a list of movies in a quick grid. Right, we've got our, oh my goodness. So we got our quick grid component here, and it's getting a list of movies. In this case, though, it's instead of the movies just being like in memory, it's actually trying to retrieve them from someplace. And you can see that it's doing that asynchronously. So there's an asynchronous action in order to initialize this component. And the way Blazor works is like when you kick off that asynchronous action, it will render the component immediately so that you can do things like render a placeholder, like say, hold on, I'm getting the movies, loading ... And then when the task completes, like when this task completes, the component actually renders again. And that's when you can actually then go in and render the data. So you see you've got this if check here that says, if we don't have the movies yet, then do loading ... Otherwise, actually render the quick grid. Okay, that's all well and good. But if this is all you do, remember, it will be pre-rendered. And then it'll be rendered again interactively. And as a result, first of all, you'll fetch those movies twice. You'll do it once for the pre-rendering and then once for the interactive render. But also, it results in this sort of weird flicker because you go through both the loading state and the data state during pre-rendering, and then the loading state and the data state when you're rendering interactively. So if I refresh this page, the movies page. Let's go to the movies page. All right, you gotta watch this carefully. Watch closely. So I refresh. You see loading, and then data, and then loading, and then data. Did you see it? It was really quick, like loading, and then data, and loading, and then data. So you got this flash. So that's really annoying. So the way you fix this in current versions of .NET is you could use this persistent component state service. I'll show you what that code looks like. And it's not the nicest code. Like you had to inject this persistent component state service, right? And then down here, you had to do a bunch of stuff. You had to say, well, let's see if we've already got the data persisted. So it checks to see if you've got the movies. If you do, you just use them. If you don't, then we'll get them from our movie service, okay? And then you have to set up a subscription, like register on persisting, so that Blazor can tell you when the data is about to be persisted. So here it's saying you'll get this event raised basically when it's time to persist the data, and then you can say, okay, now please persist the movies onto the page. And in the case of pre-rendering, it like renders it as a chunk of JSON into the HTML. And of course, this all is disposable, so you have to implement dispose as well. So that was the previous code, kind of a tedious pattern to implement. In .NET 10, it looks like this. You just have your property that of the state that you want to persist, my movies list, and you just attribute it to say it should be persisted. You just simply add supply parameters from persistent component state attribute, which I know is like the longest attribute name you could possibly imagine. We actually have renamed this in .NET 10 Preview 7 to something shorter. I think it's now the persistent state attribute. So it does get better. But the point is you just need to add an attribute. And then what you do is in on initialize, you just check, do I have the movies? Like, is it null? If yes, then let's get them. If it's not null because it came from the persistent state, then you're good to go. All right, so now if we run this app, we should get much better behavior. Cool, I'm gonna go to the movies page, and let's just refresh. We should see loading, and then we see movies, and that's it. It's beautiful. And we only went to the database once in order to do that. So that's simplified pre-rendering, but we can now use this same abstraction to make our Blazor server apps more resilient. Let me show you what that looks like. I'm gonna hop back over to my Blazor identity app that we saw at the beginning, if you remember. And this is a Blazor server app, so it sets up circuits, and it will evict circuits if you disconnect after 3 minutes and all that stuff. I don't want you to have to wait for 3 minutes for a circuit to be evicted. So I'm gonna add a little bit of code into this application just to tell it, like, please just evict the circuits immediately. Like, don't hold on to any circuits in memory. Get rid of them all for demo purposes. You shouldn't do this normally in your app, but just for the sake of demos. And so now if I run this application, okay, and there's a Spire loading up. That's great. And if we go to the app and we go to the counter page, now let me actually do this. I'm going to refresh, and I'm going to bring up the browser DevTools and refresh the page so that the browser DevTools will do what I want. Okay, so I'm going to click on the counter a bunch of times. Now, this count is really important to me. Like I carefully counted, like, I don't know, maybe it's the number of donuts that I ate today, or the number of times they said AI in the keynote, or whatever it is. This is a really important count. I don't want to lose this, okay? But then let's say something happens to my network connection, like it gets lost. So I'm going to switch tell the browser DevTools to like switch to offline mode. Now this will take a few seconds. Like it takes a few seconds for SignalR to realize when you do this through the browser DevTools that the connection has been lost. But if we wait here about 10 or so seconds, eventually the server will say, oh, the user's gone. And remember, we told it, don't hold on to any circuits, just go ahead and evict them. So it'll evict the circuit. And then now we're in the disconnected state. And then if I bring the network back, so notice that the count is lost. So Blazor reconnected to the server, but my circuit was gone. And so it was like, well, I don't know what your count was. And so it just sets me up with a new circuit, and I'm at 0 again. And that's terrible. That was horrible. So how can we fix this? So let's do what we did before with pre-rendering. I'm going to go to my counter component. And I'm going to, actually I have a little snippet to make this quicker. I'm just going to turn this field into a public property with the attribute, like so. And then let's fix up the compilation errors because the casing no longer matches. And that ought to do it. Okay, so now this component is now set to persist the count state. I've told this component, you have persistent state that I want you to keep around. And if we now go back to the app and we bring up the browser dev tools, go to our counter page, let's refresh. And then we click, super important count. Don't want to lose that, but oh no, my network connection goes away. And then I got to talk for a few seconds while we make signal R to realize that the connection's actually been dropped. Eventually, the app will realize that it no longer has a connection to the server. The server will evict the circuit, but in .NET 10, it will now persist the state of that circuit so that hopefully can be reloaded. So about right now is when we should see the connection being recognized as dropped. There it goes. Okay. Okay. So I'm in a disconnected state. Let's reconnect. Let's turn the network back on. Let's reconnect to the server. Retries. And my count is still there. My precious 5 donuts. Okay. So that's how you can make your apps more resilient. So if you have users complaining to you like, oh, you know, I swiped away from my mobile apps and I keep getting disconnected and losing my state, you can now fix that pretty easily in .NET 10 using this feature. One more thing you can do is also make your apps more scalable, all right? So we have a new client-side API that you can use to manually say you want to pause the circuit and resume the circuit. So I'm just going to add this little bit of JavaScript to the bottom of my app.razor file. And let's do this. Okay, what is this doing? So this is saying it's going to watch the visibility change event on the browser. And if it's hidden, if the browser is not currently visible, it's going to tell Blazor, pause the circuit. And remember, pause means persist it and evict it. Get rid of it. Let's free up those server resources. Otherwise, if the browser is visible, let's resume the circuit. Let's reload that data and get the user back to what they were doing. Okay? And so now, if we run this, okay, so we got our app. Let's bring up one browser and let's pop this guy up here. And then let's duplicate this tab and bring this one, say, down here. And there's our dashboard. Remember we were looking at, I need more space. Remember we were looking at the metrics before? Remember we looked at how we could see how many active circuits there were on the server? I guess we need to get to the counter page first so we actually have some circuits. There we go. Okay, so we got some counters with very, very important counts. We can see that we currently have 2 active circuits on our server. Now, let's say the user browses away from that counter and is like, you know, let me go watch YouTube for a while or whatever it is. Notice that because the browser is no longer visible, the number of active circuits is now dropping, right? It's now going down to 1. Like, we don't need that circuit right now. The user's not even using it. They're watching YouTube. And if we do that with the other one, it's no longer visible. It should drop all the way down to 0 active circuits on my server. So let's see if it's going to do that. Waiting for there's the browser visibility event just kicked in. And then if I go back to see those pages, notice that the state was preserved. Even though we completely freed up those circuits, we remembered that what their counts were, whatever they were doing in some giant form or in a data grid or whatever, we remembered and we're able to resume that state. So that's how you can make your Blazor server apps more scalable with custom policies like that to pause and resume circuits as needed. So that's the new Blazor state persistence stuff. And that's about all the time we've got for cool front-end demos. So let's go back to here. Awesome. Okay, so this is a slide that summarizes all of the new things that are coming in .NET 10, security, observability diagnostics, targeted performance improvements, and lots of top pain points and feature gaps being addressed. You can try out many of these new features right now with the latest .NET 10 preview. Both of us were using .NET 10 Preview 6, which is the bits that are available today. The next preview release, I think, is coming out momentarily, like within the next few days, I think next week. So even more stuff coming then. Reminder that .NET 10 will ship a stable release this November. We have the release party already scheduled on November 11th through 13th at .NET Conf 2025. We encourage you all to join us. Here are some useful resource links that you can consult for all the features that we discussed today, the roadmap, docs about AI and using Aspire and all those things. Thank you, everyone, for joining us today. We'll be happy to stick around a little bit to answer some questions. You can also find us later today at the reception. That's what we got for you.